This section is dedicated to solving equations when variables are on both sides of the equal sign. And we're going to start off by showing how to visually see an equation with variables on both sides, and I will explain how to use algebra tiles to solve that problem. We will be using algebra tiles in our small groups when I call you guys back to work with me. So this is how it works. If we have 8x plus 3 on the left, I'm going to write the equation down here. 8x plus 3 is equal to 5x plus 9. So, in algebra tiles, we're going to say that the green ones are positive and the red ones are negative. So we draw our line just like we do on all solving equations, but this time we're going to use algebra tiles, so it's going to be a picture, which is why it's called visual learning. The x's are represented by rectangles. So here I have 8 x's, so that means I'm going to have positive 8. I have 8 green rectangles. So I draw 8 green rectangles. And then I have a positive 3, and those are single units, they're not x's, so I will draw squares for the positive 3. So squares are single units, not x's, and rectangles represent x's. So if I draw 5x plus 9, I'm going to have 5 rectangles, and these are both positive, so I'm using green. And then I have 9 squares. Now, if you don't have different colors, you can do positive is blank and negative is colored. I'm going to have negative be red on my presentation here. So we know that in order to get rid of something, we have to do the opposite of it. In this problem, we need to get rid of 5 x's, and we have 5 positive x's, so we would have to put 5 negative x's down below to get rid of the 5 positive x's. So just like all other equations, whatever I do to the one side, I have to do to the other. So that means I'm going to have 5 red x's over here, 5 negative x's. So what I'm going to do is I'm subtracting 5 x's from each side. When I do that, I get rid of all of the x's on the right-hand side, because a negative and a positive are opposites, so these two are opposites, they make 0. So these two are opposites, these two are opposites. So a positive and a negative are opposites, and they go away. So if you look over on the left-hand side, we have opposites here, and then this one is opposite with this one. So all of these rectangles go away. Now I'm left with 3 rectangles on the left-hand side. I still have the 3 positive squares, and then I have 9 positive squares on the right-hand side. So in order to get the x, or the rectangle by itself, I need to get rid of the units. So I'm going to put 3 red squares on each side, and that gets rid of the 3 green squares here because they're opposites. Opposites go away. So over here we have opposites, so those go away. Okay, now I have 3 rectangles on this side, so those are 3 x's, and over here I have 6 single units. So what I need to do is I need to break these up into 3 groups. So I have 1 group, 2 groups, and 3 groups. And over here, if I group these into 3 groups, I have 1 group, 2 groups, and 3 groups. So that means that each x on the left, right here, each x is equivalent to 2 squares. So that means that my solution is x equals 2. I will do more with algebra tiles with individuals in the back of the room when I work with small groups. That should get you through to be successful on the digits. That was a visual way to see the algebra that we're doing. Now let's move on to the more algebraic approach. So these are the guidelines that you already knew from topic 1, section 1. And we are going to use the distributive property when possible. Then we combine like terms. Then we get the variable on one side. So number 3 is the one that is new today. So let's take a look at the examples. We're going to do it more algebraically. The top example that I just went through was a visual way to do this. Now we're going to do it algebraically. So step 1 is to use the distributive property, but we don't need to do that. We're going to learn that in the next section. Step 2 is to combine like terms. Now this is where students get confused. You can only combine like terms if they are on the same side of the equal sign. So many students would think that you could combine the 7x here and the 4x here, but we can't since they are not on the same side of the equal sign. So we cannot do step 2. Step 3 is to get the variable on one side of the equation by using addition or subtraction. So I'm going to take this 4x and I'm going to take it away from this side, which means subtract 4x from both sides to get rid of the x on the right hand side. So I'm going to subtract 4x from both sides. 4x minus 4x leaves us with 0 x's. So the 21 drops down. And on the the left-hand side, 7x minus 4x leaves us with 3 x's. So 3x plus 9 is left here. Now this problem is what we did in section 2.1. So we're going to go quickly through this. We're going to subtract 9 from each side. And we're left with 3x because the 9's cancel. And then 21 minus 9 is 12. And then the final step is to divide by 3 on both sides. And since I ran out of room, I'll write it over here. The 3 cancels with the 3. And I'm left with x equals 4 as my solution. Now see what this looks like in a word problem. So example number 2, a town has accumulated, which means gained, 8 inches of snow, and the snow depth is increasing by 2 inches every hour. Now, on the last video, I explained that every, each, per, those are key words for word problems. So every hour is going to be important. A nearby town has accumulated 3 inches, and the depth is increasing by 4 inches every hour. The question is, in about how many hours will the snowfall of the towns be equal? So, really super important is you understand that the question, in about how many hours, the question how many hours tells you that that's going to be your variable. X equals the number of hours. Whatever the question is going to be your variable. So now let's work on setting this up. A town has accumulated 8 inches of snow, which means they already have the 8 inches. And the snow depth is increasing, so that means it's going up, so we add 2 inches every hour. So we're going to add 2 inches for every hour, and x is the number of hours, so it's plus 2x. In the other town, we start with 3 inches of snow, and then it says it increases by 4 inches every hour. So we're going to add 4 inches times the number of hours, and that will tell us how much we add. Alright, so now we have the equation set up. We're going to draw our line, and my first objective, we don't have any distribution to do, so we go to the second step, which is combining like terms. We don't have any on the same side of the equal sign. Remember up here, you can only combine like terms if they're on the same side. So we do not have that in this case. Step 3 is to get the variable on the same side of the equal sign. So I have two choices. I could either subtract this 4x, take it away, and put it on the other side, or I could subtract the 2x and put that 2x on the other side. I like to work with positive numbers, so I'm going to subtract 2x. If I subtract 2x, then I'll still have positive numbers left. Let's go ahead and do that. Subtract 2x from each side. The 2x minus 2x cancels. The 8 drops down. Over here, the 3 drops down. And 4x minus 2x, if I have 4x's and I take away 2x's, I'm still left with 2x's. So it's still plus 2x. And this becomes like section 2.1. So we'll go through the rest of this pretty quickly. We need to get rid of the 3, so I'm going to subtract 3. 8 minus 3 is 5. And over here, the 3's cancel, and I'm left with 2x. And the last step is to divide by 2. So I'm going to rewrite this up here so I have some more room. Right now I'm at 5 equals 2x. So now I'm going to divide both sides by 2. I still have my equal sign there. So 5 divided by 2 is 2.5. So my answer, 2.5 equals x. And remember that x was the number of hours. So in about 2.5 hours, the snowfall will be equal. And that finishes up the first page of section 2.2 notes.